Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'm going to continue this section B topical MCQ. These are the usual section B kind of topical MCQ that students doing these Cambridge International A-levels would have been very accustomed to already. However, it's a very good practice regardless for any 16 to 18 years old chemistry students regardless, because multiple choice assesses more than one particular concept, especially with this kind of thing where we compare three particular statements, where we have statements A being 1, 2, and 3 relevant to what they're asking. Option A. Option B being 1 and 2 relevant to whatever they're asking. C is 2 and 3. And D being only 1 related to whatever they're asking. So our logic always says that we have to test for statement number 2 first. So this is a cathedral in New Zealand that has been constructed from cardboard. So this cardboard contains polymer molecules. So you have part of one such molecules. So that is something you will have seen in biology if you do it. It's called glycosidic bond. It's also the kind of glycosidic bond also exists in starch as well. So you did the structure of starch back in GCSE or IGCSE or O-level before you did your A-levels. They don't call it glycosidic bond, I guess they just call it structure of starch. But this question is not about that. It's about statements that are correct regarding this polymer. So it says, if I check number 2 first, the polymer can form intermolecular forces with water. Well, you have a OH, you have OH, 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 you have OH and OH there. So what happens with OH is you would have a lone pair on the oxygen. You will have delta plus and delta minus on the oxygen like that. So what happens is on the neighboring polymer molecule, you can also have a neighboring delta plus like that. And then they can interact like that. Hydrogen bond is from a hydrogen bonded to a highly electronegative elements like oxygen, fluorine, or nitrogen. You must show the lone pair from the highly electronegative element on another neighboring molecule. In this case, it's on another, couple of positions on the neighboring polymers. Okay, so that is what you call hydrogen bond. So yes, you can form intermolecular forces. In fact, you can form hydrogen bond. And number 1 is correct as a result, because number 2 is just saying intermolecular force. Number 1 is naming it because this is specifically hydrogen bond and not just any intermolecular forces. The polymer will not burn easily because it is a secondary alcohol. So if we look at each of these OH, the carbon with the OH is bonded to 2 other carbon. This is a secondary alcohol. The carbon with the OH is bonded to 2 other carbon. This is secondary alcohol. So there's quite a lot of secondary alcohol here. This is also secondary alcohol for the same reason. This is primary alcohol. This is secondary alcohol. So you can go through the carbon with the OH is bonded to however many carbon, right? So they will not burn easily because it's a secondary alcohol, and that is partly correct, but also because you have a long chain. So polymers in general do not burn easily, okay? But alcohols or hydrocarbons, whenever they are short chain, they do burn easily. So we need to think about this statement more carefully. So as I mentioned, alcohols in general are flammable. Okay, if you have done any experiments involving alcohol, any alcohols we consider them flammable, all right? But here you have polymeric chain, so you have a long chain. So just like ethene is actually flammable gas, because that's the monomer, but once you form the polymer, which is polyethylene, it does not burn that easily because you have a lot of carbons, each of which need to be oxidized. So there is actually not a correct valid reason, although this is a correct statement. This is a correct statement, but this is not a valid reason. Okay, the valid reason is due to the polymeric chain, for the same reason why polyalkenes don't burn easily. All right, so that is option B. Moving on to the next question. So we have this diagram which shows the monomer used to make PVC. So polyvinyl chloride stands for PVC. This is the monomer. So this is just vinyl chloride. Vinyl chloride is a chlorine bonded to ethene. Assuming that one particular molecule of the polymer they form n molecule. Well, sorry, they forms from n molecules of the monomer, where n is many thousands, obviously. So they're saying that when it's like that, and you only form one single chain of the polymer molecule. So now you have polymeric chain, no more carbon-carbon double bond, carbon still form 4 bonds, 1, 2, 3, 4, 1, 2, 3, 4 on each carbon. And it's addition polymerization, so there's no other byproduct, as you have known from your IGCSE or O level. So there are n chiral carbon atom in this polymer molecule. There are n chiral carbon atom. Well, let's have a look at this repeating unit. So that is chiral because there is a carbon bonded to 1, 2. There's a group here that will be different from this group here. So this is chiral because you have n number of repeating units like this. So you have n number of chiral carbon atoms. So that is correct. The relative molecular mass of this polymer molecule. So this polymer molecule is made out of, so this 62.5 is actually the MR of the repeat unit multiplied by however many times it get repeated due to the number of molecules of the monomer. So the repeat unit is actually C2H2Cl. So if you use your data booklet, your periodic table, 12.0 times 2 plus 2 times 1.0 plus 35.5, you get, well, hang on, what have I done? You get 61. I know what have I done. I got 61.5 and then I realized that I have counted the hydrogen incorrectly. There are 3 hydrogen, okay? So 62.5 n, okay? Oops, sorry, 62.5. But because you have n times the repeat unit, so it's 62.5 n, so that is actually correct. N is only approximately, we are not entirely sure because there's something capping the polymer at the very end as well, yeah? Next bit, there are 5 n sigma bond in one polymer. So if you look at the repeat units, again, the focus is on the repeat unit. On the repeat unit, you have 1, 2, 3, 4, 5, 6, 7 because you form these 2 additional sigma bond. Because you have lost the pi bond, you form 2 additional sigma bond. So there's 1, 2, 3, 4, 5 from the original monomer, the sigma bond. You lost 1 pi bond, so you add a sigma and you add a sigma. 5 plus 2 becomes 7. So it's actually 7n sigma bond. So 3 is incorrect. We get option B as the correct answer. In this next question, so polyethylene and PVC. So polyethylene is just from ethene as the monomer, and PVC was covered in the previous question, polyvinyl chloride. It's actually a case study ever since your O level or GCSE or IGCSE, yeah? When we buried them in a landfill site, it will not significantly biodegrade. That is correct because of the non-polar carbon hydrogen, and of course we have strong CH and CC bonds. Those are partly the reasons why they don't get hydrolyzed easily, and also why it's very difficult for alkanes in generally to react, because when you have polymer, you mainly now have lost the alkene functional group. You now become just long chain of alkanes. On combustion, PVC can produce carbon monoxide. When you have incomplete combustion, you can have complete combustion and you will produce carbon dioxide, and you can also produce HCl, because a lot of things can happen when you combust PVC. If you think about the structure of the monomer for PVC, it does have chlorine, okay, it does have hydrogen. At some point when you combust it, you can get HCl, which is a corrosive gas. All right, so you don't want to burn PVC, otherwise you'll be producing HCl again as a gas. The empirical formula of an addition polymer is the same as the monomer. Empirical formula is the simplest ratio of atom, and as we know it, in an addition polymer, if you have C2H2, basically C2H4, sorry, that is basically your ethene. You have n number of molecules, and then you get CCHH like that as your polymer. All right, so that is your empirical formula is going to be C2H4, and that is NC2H4. So the empirical formula is CH2, if I just think about the simplest ratio, both of them have n, so you can cancel out the n. They also have 2, so you can simplify them as like this, and therefore the empirical formula is just CH2. They are the same, and this is something you will have known when you compare addition polymerization versus condensation polymerization from your GCSE polymer or your O-level polymer, because compare addition versus condensation polymer is actually something you have done from that level. The next question, so polymer Z contains the length of that polymer chain. This short chain of polymer is found many times within the chain, although it is not a repeat unit, but you found it many times. All right, so what is the repeat unit and what could be, you see, what are the potential possibilities? All right, so I guess if I just draw it out, then perhaps it can be clearer. So this is not the repeat unit, yeah? That's what I said, this is not the repeat unit. So let me check option 2. If I have polychloroethene, so that is vinyl chlorine, it just have one chlorine on an ethene molecule. If I form a polymer, I can get, well, I can get this. This is possible, right? Because I'll show you what I mean, okay? If I have that and I have this added in that manner, so if that adds in this way, so what happens is you can get carbon, 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 carbon. So I'm just showing for a few. Obviously, like in exam, if you can see it, you will just move on. So this is like continue and continue. Of course, you have many monomers. Okay, I'm just showing you 2. If they add in that order, then you will get that particular order. Okay, so that three things here potentially could be what you see. So 2 is perfectly possible. All right. Hang on, let me think. Chloroethene, polychloroethene. So you know this is chloroethene. All right, you know that is chloroethene. You also know PVC stands for polyvinyl chlorine, and you know that vinyl chlorine is equal to chloroethene. Yeah, this is vinyl chlorine. This is also known as chloroethene. So polychloroethene is actually PVC, which is polyvinyl chlorine. It's the same thing, right? So if number 2 is possible, number 3 is the same thing, because they are the same thing if you know anything about your case study, okay, on your addition polymer. So I just need to check number 1, all right? So based on the name, number 3 is correct. So if I check number 1, poly-2-chloropropene. So I have chloropropene, poly-2-chloropropene. Okay, I guess I should probably draw the display so that it's clearer. So 1, 2, so that is polychloropropene. So that is 2-chloropropene, prop 1 in, all right? So I can tell 3 is wrong straight away because what happened is, I hope you can see the CH3. The CH3 is always on the same carbon with the chlorine. The CH3, there is no CH3 on the carbon with the chlorine. This is the carbon with the chlorine. This is the carbon with the chlorine. There is no CH3 there. Therefore, it's impossible. It's impossible to get number 1. Doesn't matter what it forms, but the CH3 is bonded to the carbon with the chlorine. And in this sequence, you found it many times. The carbon with the chlorine has no CH3. I can cross out 1. All right. So 2 and 3 are correct. That is option C. This is the last question of this 5-question series on polymerization of polymers. In AS, that relates to just addition polymer. But of course, in A2, you continue further to condensation polymers. Yeah. Which statements about polyalkenes are correct? So we know that when we dispose polyalkenes by burning them, they can produce harmful products. One of which I can always think about is carbon monoxide, which is toxic to us as human beings, because they can bind to your red blood cell irreversibly. Okay, so it's like a silent killer, and you get this because polymers don't burn easily because of the straight chain. You get incomplete combustion, and therefore you form carbon monoxide. So that's correct. So polyalkenes do not react with Br2 in the dark. This is correct because normal carbon-carbon double bond. How can you do electrophilic addition? So do not react is correct. Polyalkenes do not readily biodegrade. Yes, we call them non-biodegradable because they do not hydrolyze easily. Okay, so not easily hydrolyze. So what are the kind of things that easily hydrolyze? There will be esters, there will be amides, things that you have done as condensation polymer from O-level, from GCSE, from IGCSE, something you will revisit again in A2. Okay, I wish they put condensation polymer straight in AS, but Cambridge decided to just split them, so who am I to say anything? Alright, so that's the end of this 5-question series. If you found them useful, do share the channel with your friends and your class chat groups and whoever else you think this channel might be useful for. Alright, so someone if you share with them, then they might benefit from it. Alright, okay, so click on that button at the bottom right, subscribe to the channel, and thank you for watching. See you in the next video.